Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of quadratic domain and range. This is standard A.6a in the great state of Texas, and we are using item number 30 off the Redesign Practice Online STAR Test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we need to find the range of this function, and if we look on our reference material, we're not going to see anything that's going to define domain or range. So we need to bring the knowledge of those vocabulary terms in here with us. So let's first ground ourselves in what the difference is between the domain and range, because those two are sometimes asked together. So the domain is the set of all possible independent variable values. So the independent variable values are going to be our x values. So we're not looking for the range of all x values, and typically it's going to be all real numbers. So there's not really much work there. Unless you see a graph that is partially chopped off, it's going to be all real numbers for the domain. Now the range, that changes. So since the domain is the set of all possible independent variable values, then we want our range to be set of all possible dependent variable values. And sometimes this doesn't work as well as it should. That's going to be your y values. In this case, it's actually going to be your f of x values. I've seen it be g of x, even h of x. Just think of them as your dependent variable values. Now, what do we know about this function? We do know a few things. If you are looking at it, you should notice that it is actually in vertex form. So I'm going to show you right here our quadratic equation. You look down at the bottom, take a look at that. It's that f of x equals a x minus h squared plus k. If we recognize that this is in vertex form, we're in luck. So let me write that for us real quick. F of x equals a h, or x minus h squared plus k, because I need the h and the k. If I get the h and the k, that's actually the x and y coordinates of my vertex. So what do we know about this? Well, we know that this is a graph, and we know it's got a vertex of, look at this, 25 and 13. Those are the xy coordinates of my vertex. So if I want to say it's x of 25, y of 13, my vertex is going to be about there. Now, the direction it opens is actually in that a right there. If it's a negative a, it's a downward facing. If it's an upward a, it's going to be, or a positive a, it's going to be an upward facing. So it's going to look like this. Something along those lines. So if I want to know the range, I'm looking for the set of all possible y values. Right? So I know that my y is going to be, since it's facing up, greater than or equal to, what is this y value right here? It's this 13. So I'm thinking it's d, but since we have our calculator, let's go ahead and just calculate this. So we're going to open up our TI-84. Let's open up our y equals, and let's plug this in. We need to hit the alpha link to get our fraction, 2/5, and then it's going to be x minus 25, hit the squared, and then we'll add 13 at the end, and let's graph it. And if we see this, if it's zoomed in like that, we can't even see anything. Remember, it's way over, so we need to zoom out. And we should see it in that quadrant 1 popping up. There we go. So it is upward facing, and I'm going to trace, and I'm going to bring it all the way down. And there we go. Let's see if we can find that vertex. Looks like it's, yep, right there, right about 13. So our answer is going to be D, all real numbers greater than or equal to 13.